Hey, hello. So my name is Kuba, and I wanted to talk a bit about unit testing in Python, but to be honest, I would be mainly focusing on PyTest. So I want to present my point of view on testing in Python. Somebody might disagree with me, but PyTest, I will show advantages and I will show strong points of PyTest. So I hope to convince you that it's a great framework for testing. So you will see in a minute or few. Few words about me, where you can meet me and why am I doing this talk. You can meet me on most of the PyConic events here in Kraków, and you can meet me on PyCon PL conference or other conferences where I try to always tell something, speak about something, or do the riddles competition. And recently, at the beginning of the year, I have prepared a video course on testing in Python. So it was very basic video course for people with nearly no knowledge about Python. And during creating that video course, I found a lot of interesting stuff in PyTest that I didn't use, even though I programmed for last 10 years. And I want to share those things with you. So the presentation would be mainly hosted in the Jupyter Notebook, and that's because Jupyter lets me give a presentation that will be something in between the live demo and static slides. And there is a hidden motivation behind that, is that I want to encourage you to ask questions while I speak at every cell executed, because I can edit them on the fly to show you some in-depth, because maybe I skipped something. Okay, so first thing that I want to say about unit tests is unit test library. So the first load-ext is just loading the hook to run PyTest in Jupyter Notebook, so don't worry about it all. So first, before I even start talking about unit tests, I have a question. Who of you writes tests for the code? Okay, and who of you likes to write tests for his code? Okay, quite a lot of you, so that's good. Usually it's not that much people raised hands, and I want to show how to write those tests easier. So the main focus of this topic would be unit tests, which are the most basic kind of testing. And I don't really want to cover another parts of tests. I will be speaking about these lower tests. And these are the tests that Python developers need to be most familiar with, because that is something that defines what you write. And I guess that everybody has seen a code review in his life saying, please, like, rejected, please write tests to that. So that's something that we should do, because with unit tests, our code is much more reliable and much more bulletproof for adding additional extensions. And 100% coverage, it doesn't mean that our code is perfect, but it means that we at least should catch stupid failures that we will do in the future. And we can promise to ourselves that we won't, but we will. So unit test, that's the basic library in Python. It's a built-in. PyTest, which I will be mainly talking about, is an external library which we need to pip install. But unit test is there. So if we have a tool at our hand, why to use another one? Because unit test has few concepts that makes tests more obscure and less readable, less reusable. And the first one is the main idea behind the unit test. So I wrote a very simple +1 function, which adds 1 to the number that we have provided. And to write a test case for such simple test, I need to prepare the unit test case, and I need to write my test as an additional method, and I need to know that I want to call the assert equal and not assert something different, because unit test has a lot of kinds of assertions. And then I have to execute the test with the unit test main, and also these don't care about this one. This one is only for Jupyter Notebook, so it's needed here. So there's a lot of things that I need to add, which I will be adding nearly all the time for most of the tests, and this will be. When I wrote tests, I wanted them to be as clean as possible because tests are often used as a part of a documentation. When I don't know how the function works, the first place I go to check are tests that are invoking this function. That's the easiest way. The documentation is the second place because the documentation might be outdated, which unfortunately often happens. So one test, fine. And another part with unit test. So we have failing test. The output of the unit test is more messy than the output of the PyTest. When we have a lot of unit tests in our code base, is often easier to read the failing task while running the PyTest. The additional part of that is, okay, so in big projects, in case I forget about to mention that later on, we often want to discover the tests from different files. So each file might have its own test cases. PyTest does have a pretty good, pretty decent test discovery, but I will cover that later when I come to the project itself. So we have our first test that has failed because 4 is not equal 5. So that's the most simple test case that we might have written. But let's consider another part of code. So this time we don't have +1, but we have the, let's say, generator function that will generate the, not Python generator, but that would generate the +x functions. So we can create our own +1 or +3 function. To do that, we need to probably we'll have multiple tests for that. So using unit test, we can write a setup function that will define our plus function for us, and then test on that. What's wrong with the setup? The setup function will run before every test. So if we don't care about our whole test case being using only the things in the setup that we really want, we might finish up in having 20 test cases in one test case, 20 test functions, and every of those will invoke the setup, and we might run in the situation that we're invoking in the setup something that only one test uses. So we're using the memory of the computer, which we really don't need. It's totally unnecessary. So why should we do that? And of course, this one runs correct as well. So one test is okay. So how would that look with PyTest? It's just 2 lines. So if we want to test +1, we just assert if +1 of the number is equal 4. PyTest doesn't have any, well, it has helpers for example, fuzzy equal for floats, but by default, it only supports one word. It's just assert, which is a built-in word in Python. And some people might disagree that it's more handy in the unit test that we have, for example, assert true or assert false, but we can write in the assert the very same assertion, and we will be sure what we are asserting. I don't remember now, but I know that one of the unit test names is a little bit, name of the assertion in the unit test is a bit misleading, so you might think it works a bit different than the name suggests. Okay, so that's a very simple case in the PyTest, and of course it has test session starts and 100% fine. So what can we do? What would be more interesting? We can have a failure. So how does failure look? Pretty similar to the unit test in a simple case, but of course we have assert which line failed, so +1 of 3 equals 5, and as the failure was that 4 was not equal 5, where 4 was +1 of 3. So it's a lot of information comes to us, so in most cases, we nearly immediately see what has failed and what to do to fix that test case. I mentioned that there is only one assert, but that was not true. There is also one very, very important thing PyTest raises. Just one question. Does everybody see that clearly? Because I can zoom in a bit. Yeah, okay, that's clear. Okay, so PyTest raises. So whenever we try to do something that we expect to fail, we can run the with block with the exception that we expect to be there, and PyTest will catch that. If we change that to, let's say, import error, it will fail because because it didn't catch the error at all. So so it's just a type error. And if we try to expect that it will fail, but it won't, it will also fail on the did not raise. So PyTest covers all of the cases for us, so it must fail the way that we are expecting. So we were talking about the generator, so the plus something function. And first of all, that's a very simple test case, but I want...
One question about the
Sure.
itself, because can you scroll up?
Yeah, sure.
Because here we have also assert plus one.
Sorry.
Good idea. Like
No, it should be like that. Yeah, sure. With the PyTest raises, in the with block, it's good to only execute the code because it will fail. There is no point in asserting that. Yeah, good point. So one point that I want to say about a good practice of writing tests. These are those 3 words that people often even write them literally in the test code, but you don't have to do that. But it's good to always keep in mind this structure when you write a test. So given a situation, when I do an action, then I expect a result. And you should never confuse the order. So the test which implements some stuff, then run some actions, do some assertions, run some other actions, run some assertions, etc., etc. This is not a case of a good and readable unit test. This is not a test that you can rely on. And the given when then is a pretty simple structure that is good to keep in mind. And a lot of developers apply to that structure, even just by giving a free white space in between the test cases, and it makes them a bit more readable. So at the end of the test, we only expect assertions. So what do we have next? We have the plus x function, which generates the plus inner. And in this situation, now we have few of the test cases. We have plus x positive, which checks if the 3 plus 2 will be equal 5. We have plus x negative. We have plus x float, and we have plus x infinity, because why not? So we have a lot of redundant tests. So another good practice that all of the developers should have in mind is the dry rule, don't repeat yourself. We have a lot of repetition. So let's imagine that now the plus x name changes, for example. We need to find all of the usages, change that, and well, that's not the worst that can happen, but there's a lot of additional work. So there is no point in writing tests like that, and it's a common practice that a lot of tests is being repeated in the unit test. Let's try not to produce additional tests, and that's where the first great tool of the PyTest comes. It's PyTest mark parameterize. So how it works? We can use a decorator PyTest mark parameterize on top of our function, and say that we will be using those arguments. Those arguments is a string with a comma-separated values. So what I usually do is I define them here or here and just copy-paste them into a function. It's the very same format. And then it accepts a tuple with the tuples that we want to pass. So we can pass that the base and the expected, and then we create our plus 3 function, and we will be adding 3 to our base, and we will be expecting the expected value. So in this case, it will behave like if we have 4 test cases. So for PyTest, it's not a big difference. It still says that it's like 4 separate tests, So let me fail on one. So on the first one, now I run them, and I have a failure. And here, that's where also PyTest shines. So it says that our test plus x test has failed on the arguments 2 and 4, so exactly the one that we were passing, even further, when the base was 2 and the expected was 4, and it failed on the assertion. So everything is in here. If we, let's say that we fail in here, yeah, with the it follows up the floats as well, and it doesn't follow iterables. So let's write a very stupid test like 1, 2, 3. Of course, that won't work, but in this case, it will be expected to. So the 0, 1, 2, second iterating from 0, second example that we do. So even if PyTest can't really format that, it will inform us on which one has failed. So marking as parameterized, now that there's one warning. It is very easy to get trigger happy with parameterizing your test cases. It's not the point, well, the only point to fill in few variables in here. I would say that there are 2 points. The first one is to go through all of the conditionals inside your function, or to provide a little bit of a documentation on what you might expect your function to work. There's no point in having a situation where we want to make sure that 2 plus 3 is 5, and 3 plus 3 is 6, and let's say 12 plus 3 is 15. This only adds additional test cases. It will make our tests slower in the end, and we want our tests to be fast because we want to execute them every now and then, every time it is possible. So try not to be too trigger happy with parameterizing your test cases, because this functionality is great, but it requires developers to be responsible. Sorry? When it's wrong, yeah, sure. So, yep, like that. So it says that for the base 2 and expected 4, the assertion has failed. So we know which of the cases that we've provided has failed. What's next thing that we can do? Sorry, I think I duplicated this one. Okay. So what's the next thing that we can do? We have this +3 in here in our test case. And considering that we'll be adding more tests, we will need this +x implementation in every of the tests. That's where another great tool from the PyTest comes, PyTest fixture. So fixture is the most magic part of PyTest, which a lot of people doesn't really like that much, but when you know how they work and you know what are the possibilities of the fixture, they are not that magic anymore. What that does, it defines the +3, which will always be our generated +x of the 3, and it will make it available as an input argument to any test in our scope. So in this case, we might have the test +x, which accepts, of course, the base and the expected, which are coming from the parameterization, and accepts the +3, which is here, and we can immediately use that. So fixture is exactly the thing that PyTest, well, not exactly, but this usage of that would be exactly the same thing that unit test would do when we run something in the setup, except it will only be executed when we add that to the argument. If we now write additional test but without this +3, this code would not be executed at all.
Will it work with new introduced in Python 3 keyword only arguments? So for example, if you put the empty star before the +3, will it work?
Oh, I don't know. I haven't tried that.
Can you try that?
I don't know which Python exactly is that, but it's... Yeah, okay, you're right, true. So in here, like that?
Yes, like that.
Let's see. Looks like it works. Okay, and I mentioned about the fixture, and the fixtures does have a few of the good functionalities, but I will cover that in a second when I switch to a more reliable, more realistic example, because let's forget about plussing numbers, it's boring. Let's say that we have a very simple application that we want to write, which we call a calculator. So we have a calculator which, calendar. Too much of the adding numbers. We have calendar, so our calendar can have a list of the events, and we can add events to our calendar. What it should do, it should additionally parse our message that we add, in case because we would like to have the date-util parser, we want to save when. So it's like the Slack remind me on 10th of September to do something. We want to have a calendar like that. So first thing that we might want to do is a PyTest fixture for a calendar, and I will later show a few examples what interesting we can do with that. And we have few parameters. So that's one of the examples where parameterizing is not a bad idea, because we want to show a few of the possibilities how we can call our function, and we want to prove that it's not just one string format, date format that we accept. These are different formats, and if we don't have any date in the name of the function, then it's totally fine. The one will be empty. Yeah, and we have 3 tests passing. So we have 2 assertions in our test case. So we try to add the message to our calendar. So the message is each of those messages, and we assert that the events in the calendar are that there is one event in the calendar, and that the when of this calendar is equal to the when, so for the date time that we expect there to be. Is that clear for the moment how the calendar works? Okay, so let's show what interesting we can do. This is pretty strange example, but I couldn't imagine any better. Let's say that we have a delete function for a calendar that would warn us when we delete a calendar that has any future events. Why that? Because I want to show that there is a possibility to catch a tear down on the fixture. In the unit test, this is a tear down function. In the PyTest, we do that this way. So we have a calendar function, calendar fixture, which implements our calendar, yields it back, and once the test has passed, at the very end of the execution, we call the delete. So what should happen now? It should raise an exception with the "Are you sure?" message. Sorry, it's here. Yeah, and it has been raised. Are you sure you have future events in the calendar? So let's say that for now we want to force true, and that is now passing. So there is a possibility to add the tear down functionality to your fixtures. What else interesting can we do with our fixtures? So that is something that is not often used, but it's really good to know that it's possible to be used. I have removed the delete functionality, but let's say that our calendars are time zone aware, so we want to localize our events to the time zone that we have provided to the calendar. A simple example that can make the code very messy, and our calendar should work exactly the same. Well, it should work with the time zone info given or without. And to achieve that and to duplicate all of our tests that we have, we can parameterize our fixture. So the fixture accepts the params argument. Then we can say that we want it's not called tz info yet, but we want to test it in 2 scenarios, for a non-tz info and for time zone Europe Warsaw. That's an interesting part. So PyTest does have hidden fixtures, which comes by the installation of the PyTest. There is a function to list all of the available fixtures to your tests. I don't remember the name of the function right now, but it's easy to find it. Request is one of the PyTest built-in fixtures that we can use. So to get into the params that we pass to the fixture, we need to use the request, and it's under request.param. So right now we are creating two calendars. The first one will be created with known time zone info, and the second will be created to Europe Warsaw. And considering that we also have 3 test cases, that should produce six tests. So these are failing because I'm comparing the time zone aware datetime with non-time zone aware, and here are our 6 test cases. So that's a point where we need to edit our tests a bit, and we want to compare the parsed when to the time zone info localized datetime if the time zone info is in the calendar, or to simply when, so given datetime if there is known. So when I run it now, there are 6 tests passing. So these are 6 tests that I have generated with just adding these few words. So a very easy way to multiply your test cases. I've done the lightning talk in a previous how to get from 1 test case to 16 test cases, showing different functionalities of the PyTest. So it's really easy to multiply your tests for different scenarios. So let's talk about talk a bit about a different scenario. Let's say that we want to synchronize our calendar. So we can pass the sync call, which will be some kind of the URL where we will be posting our events, but events as an events dict because we want to parse the when to ISO format, and we need to JSON dump because we were doing the request post. Probably it could have been written better, but that's not the point. So we want to sync our calendar. So if the sync call is there, we will be making a post to the sync call. And it doesn't have to be there because it's an optional argument to our calendar. So of course, let's create more fixtures. So now we have 2 separate pairs of the scenarios. We can either pass the sync call argument, or we cannot. And we can pass the time zone argument, or we cannot. So our calendar will accept those fixtures because fixtures can accept other fixtures as parameters. That's totally fine to do. We can chain it like that. So our test case is just that. So we just want to add an event, and we want to verify that the sync has worked. Now this is getting a little bit out of the typical functionality of the unit test, because we will be testing multiple functions of the test, because we expect the event to work and we expect the sync to work, but I will cover that in the next steps. But let's run it. Okay, so 4 tests has passed. So if we have the sync calendar, or if we doesn't have, it will run. And as you can see, it's much slower because we're making the post request. So it's really making this post request to example.com. Sorry, the owner of the domain, for spamming, but I think everybody spams you. So that's one thing. We're making requests to third-party library. We never want to do any request in our test case. So that's like a rule of thumb for writing unit tests. Don't use requests. And there is a great tool that I often use, the no requests magic fixture. And that's a very handy tool. And let me describe what it does, because it uses few things that I already mentioned and few that I haven't. First thing to mention, I assume we're using request library only. So maybe too broad assumption, but for this one it works, and it's just a handy fixture. The auto use true is a funny argument that will always behave like we have added that fixture to our test case, but we don't really need to add that. We don't need to remember about it. It will always be there. The other thing that is important for the test cases is the scope argument. So there are three scopes available. This is function and module and I have something for the whole scope, which I forgot. Session, yeah, and the session. So it defines at which how broad our fixture is. But for this case, let's not get into that kind of details. The auto use, it will be used automatically. What is the monkey patch? The monkey patch is something that I'm slowly getting into. So we don't want to do our request. We will be monkey patching our functionality, our code. The monkey patch is a built-in PyTest fixture for doing the mocks and to edit our context. And the built-in is not that useful, but it has one nice functionality, deal_add. So what we're doing with this fixture, we're just deleting the session.request function at all. So every possible request with request library should now return the information that it's not possible to use because there is an attribute error. And I think that it should call an attribute error. Session object does not have attribute request. So let's fix it, and of course not fix it by commenting this out, but let's fix our test. So to fix that, we will be mocking the request, and I think that's in here. Yep. Yeah, so I commented it out, so the request should work normally like they did, but I've added a mock to our function. So just one thing to keep in mind, the patch comes from the unit test library. Actually, it's one of the best functionalities in the built-in unit test library in Python. So we have this built-in patch for patching our functionality. There are two patches, let's say, that we can use, patch object and the normal patch. It's imported, by the way. It's imported from unittest.mock. So the patch object gets our object, so in this case, the request that we have imported for our tests, and patches the post functionality. So the post should behave different than it should do by the default. So what we can do with that, for example, these assertions comes because our calendar can be with the sync URL or without. So if we don't have our sync calendar used, we will not be calling that, and we can call something like pytest.skip. So pytests have a way to skip the tests without failing. Another way which is useful is xfail, which means expect failure. So we can expect that our test fails, and when we have an issue in our test cases, but it's not that big, we can fix that later. We can show tests as expected to failures, or we can skip because of some reasons. In this case, the reason is that this mocked this parameterized fixture calendar doesn't have the sync URL. So what we'll be doing in here, we'll be adding a message to the calendar, we'll be syncing that, and we'll be expecting that the request.post has been called with http example.com, which is our sync URL, and with the data, which is JSON dumped event sticked. And that's exactly what it would do. So 2 tests are skipped and 2 have passed. So just to uncomment that, because I want to prove that we're not doing any real requests. Yeah, we're not doing any requests at all. So all of the third-party external functionality is now being reproduced by our own behavior. But there's no real behavior, because we only assert if this mock has been called with. So mocks does have few functional assertions. The most useful is just assert code or assert code with, and it has a whole. You can access the whole list of the calls on that mock. So how many times the request.post has been called in this test case. But let's say that we want to. So this is the nearly the same code, and I wanted to show what really happens in the middle. So we use a decorator to mock the whole function, but we can do something like that. So mock is also imported from the unit test mock. So along the path, now I import mock and magic mock. So I will be showing what is that, so how this decorator worked earlier on, and what's the difference between mock and magic mock. So let's say that this time our get date from message, because now add event gets the when with the get date from message function. So I just extracted the code from the add event to a separate function, and it does exactly the same. But it's a unit test, so we want to test the minimal functionality that there is. So our get date from message, from now on it will be mock, and this will be a mock with a return value of the test. So what happens now when we call the add event? We will have the one event with a message equal to the given message, and with a when equal to the test, which is mocked. So this one works fine. And there's another test, the one that uses the magic mock. And what's with the magic mock? And magic mocks enables us to mock the magic methods. So the magic methods in Python are those which starts with a double underscore and ends with a double underscore. And one of the examples is the equal function. So this test doesn't really have much sense, but I wanted to show the difference. So we have a version in our calendar, which is point to 0. And this is like a magic attribute. It has double underscore. With the magic mock, we are enabled to create a mock on that version, and there's a mistake. Of course, it should be like that. Call version, and it's failing because in assert I have. And I think that's why probably now I can do just like that. Because equal. Okay, so let's keep with this version. I will investigate that later on. So we can mock the magic methods with the magic mock. In theory, we usually use magic mocks, and patching uses magic mocks. So magic mock only gives additional functionalities to your normal mocking. Okay, so let's go a bit further. So what we can do with mocking, earlier on I have mocked the whole function. So everything that happens in the function is in the mocked context. But what I really enjoy with PyTest in general with testing, is only mocking the lines that you expect that will be using the mock. So I usually, personally, don't write those decorator big mocks, but I use the with context. So with patched calendar with a get date from message patched, which will return value test as some kind of a date mock. I call add event, and then I expect that to return the events like that, and I can even assert date mock assert code, and I have one test that has passed. So the events of 0 is still in the context with patched get date from message, and this mock has been called at least once. So this is passing fine. So as to wrap up the PyTest functionalities, the PyTest tools that we have that are good to remember to use. First of all, it's parameterization, and the second part is the fixtures. These are two things that it's good to recap and to get back to that later on. And let's get back to presentation. And I want to mention a few things about TDD and katas. And okay, so about PyTest, a few more words. The PyTest has pretty good test discovery. and I wanted to show briefly one kata in a TDD. I'm sort of running out of time, but I will show that very shortly. So let's say that we have a PyCharm with PyTest running on the run function. What is a great tool that we can do is practice ourselves with solving some TDD katas. TDD goes from test-driven development. So you first write the test that you expect to fail, and then you write the function that will pass your test. And then you're using the baby steps to move forward and to fill in the correct code of your function that will make the tests happy, and then you can refactor. And katas are a simple example like the one I gave here, the is anagram. So I will be checking if those two messages are anagram. So first of all, I will create test is anagram success, which will assert is anagram of test and anagram of test. I'm giving the most stupid, smallest example that's possible. And of course, this is failing. So let's write the simplest solution that I can do. So I am checking if message 1 is equal message 2. Okay, my tests are happy. So let's write more of those. Let's check the test is anagram fails. And let's check if test is an anagram of tests. And of course, it's not. So in the next iteration, let's say that I will be checking if set of the message is equal the set of the message 2. And we're happy with that because we're comparing sets now. But let's make another failing anagram. So I'm showing you now how usually solving a kata works. And this time let's test with the test. And this one is passing, so our code is fine. But we can, sorry. Yeah. Yep, you're right. So our test is not passing because this one is not an anagram of that. So I will do the, I will do the easiest way to solve that with, let's just use sorted instead of set. So I will be checking if the sorted message is equal sorted, and I'm fine. I have pretty decent test coverage for a small function that I have written. I have tested the correct scenarios and the failed scenarios. I can now parameterize that, but I don't really have time for that because I want to show one more functionality. It's run with coverage. So the coverage is very important functionality for your tests, and it's worth to always check how much coverage of your code there is. Right now we have 100% lines covered. If we say that if message 1 is equal not test, and then return false, for example, because I just want to show you how it will work like, and now I run with coverage, there is no argument, not test, so our test cases will never get into this line. So our kata says that 75% lines are covered, and we have a small red line in here saying that this line has never been visited by our test case. So it's good to remember to check your coverage once in a while. Of course, if you have a legacy project and you run a coverage and you see 2% of the coverage, it's not it's not the first thing that you should do is to write the test for everything, because that would be very hard to do. But it's worth to add tests whenever you have to fix something in the code. So one example, whenever you have a bug, like reported bug, unexpected behavior of your program, something has failed, the best way to solve that problem is to first write a test case for reproducing the failure, and then implement your code that would test that, because you will add your test to the coverage, and you will have the reproduce error on your local machine. So you're a winner at that situation. And it's much better than just writing a code without that. So that's a part of the TDD. So it's often good to first write your tests and then write the code that will fill those tests. Okay, so the time is up. So I want to thank you and ask about questions. And one more thing that I want to tell is that these are the cards for a 20% discount of the course. It takes 3.5 hours, so it was pretty hard for me to squeeze it all into 40 minutes. That's why I extended a bit. Sorry for that. But if you would like to hear it all, there is a 20% discount. And you can surely ask any questions now about the test case.
One question, maybe, at least.
Okay, it's more of a philosophical about questions, because you showed us patches and mocks, and do you think it's generally a good idea to unit test things that are functions that are making some external calls and are not pure functions itself?
I would say that it's good to test that because...
unit test that.
Unit test that. Yes, I would say that it's good to do because of two reasons. The first one is that the documentation part of the test that I've mentioned, it's good to know what you expect from the third party to return, and that's the easiest way to write it down in your test codes in your code base is to write it in tests. It's better to write it there instead of the documentation, which can be outdated. And the second part is, well, you can reinvent your code so that you have some kind of a service that will call the third party, but still there will be a point where you will find a function which calls something that will get this code from the third party, let's say from the API, so some response. So in the end, if you decide not to unit test that, you will lack a bit of a coverage because the others. Okay, so one more thing, that there is another solution to use that which I haven't mentioned, and that's getting a step more deeper than from unit test. So we're more in the integration test, and there's a cool library called VCR. So instead of mocking your responses from the third-party services, you can record them and store in your project. So with the VCR, you just run it once and say that the first response that you will get, it will get saved to your project. And then all of the next calls, instead of calling that third party, will just return the mocked response from that. But yeah, I agree that it's not strictly a unit test thing, but while we develop the code, it's important to think about the coverage for me, more about the coverage than about, am I writing a unit test or is it an integrational test? So maybe I won't write anything.
No, but I think it's more in integration, and thanks for the VCR, I will check it out.
Okay, then
you can catch me later on,
yeah,
because we're really running out of time.
okay, so big round of applause and thank you.
Thank you.